Hey, what's up everyone? Today we're going to be looking at the difference between physical and chemical changes. And this is Unit 4.1 in the AP Chemistry curriculum. Okay, so there are two types of ways that a substance can change. First of all is a physical change where you have no change in composition, and then you have a chemical change where you do have a change in composition. Physical changes include things like change in shape, texture, color, temperature, and phase. And chemical changes include changes in odor, color, the formation of a precipitate, changes in temperature, and the formation of gas. If you notice, there's changes that are in both categories. Like you have a change in color as a physical change and a change in color as a chemical change. And we're going to be looking at the difference between these sorts of changes and why one thing is a chemical change and one thing is a physical change. Let's start with some physical changes. So remember, a physical change can be something like a change in shape. For example, you have these sheets of aluminum that you can make even thinner and you get aluminum foil. Aluminum foil is mostly aluminum. There's some other stuff in it, but you basically just take a bunch of aluminum and you make it really, really thin. And you can take that aluminum and you can make a ball of aluminum. You're changing the shape, but at the end of the day, it's just aluminum. So a physical change, a physical change includes no change in composition. And in this example, you have aluminum and you still have aluminum. Okay, so another example of physical change is a change in texture. So if we're staying with this aluminum foil analogy, you can take aluminum foil and you can sand it to make this really, really smooth ball. And this is some guy on YouTube doing it. And this doesn't change the composition, it's just aluminum. You've just sanded it to make it smoother. You've changed the texture, but you haven't changed what it's actually made of. Another thing is a change in color. So let's say you have some blue water, or you have water and then you add some food coloring to make it blue, and you have some water and then you add some red food coloring to make it red. If you combine these two solutions, at the end of the day, you still have water and you have your food coloring, but your food coloring have mixed, so now it's purple. If you don't remember, red and blue make purple. So you have purple, but it's just still water, and then the blue and the red food coloring have combined to produce purple. That's a physical change. You have a change in color, but nothing has actually changed chemically. Another physical change is a change in temperature. If you take water and you heat it up, it's still water. And this leads us to our next example, which is a change in phase. If you have ice, that's just solid water. And then if you have water, that's just liquid water. And in a cloud is just gaseous water. It's still water in all three phases. So the whole water cycle is dependent on lots of physical changes. Again, all these are water. Nothing has actually changed except for the phase that the water is in. Another change in phase that we can look at is dissolving something. So if you have salt and you add it to water and you mix it up, you have just taken salt and you've made it aqueous. That doesn't actually change what the salt is made of. You still have sodium ions and chloride ions. So a change in phase is still a physical change, even if you're dissolving it. Let's look at some chemical changes. Let's look at a change in odor. So if you have milk spoils, and I don't want to show a picture of spoiled milk, but you can smell spoiled milk. And the reason why milk spoils is because bacteria in the milk turn lactose into lactic acid. And usually lactic acid doesn't smell bad, but if you have a lot of lactic acid, it smells bad. So those bacteria are causing chemical changes, turning lactose into lactose acid, and you have a change in odor. As you know, spoiled milk smells pretty bad. So a change in odor can indicate a chemical change. Let's look at a change in color. Let's say we have iron rusting. This is unrusted iron and this is rusted iron. Unrusted iron is this kind of silver color, and then rusted iron is this like brownish color. And that's an indication that a chemical change has happened. So in this case, you have iron mixing with oxygen and water to produce oxidized iron. So that's rust. This is why your mom tells you not to leave your bike outside, because outside there's oxygen, there's water, so this reaction happens to produce rust. So why is this different from the change in color that we had with the water? Because this actually changes what the substance is made of. This is no longer iron. The top coating is iron hydroxide. or rust. And then inside you do have the solid iron, but remember outside you have a reaction happening to produce the rust. Okay, let's look at the formation of a precipitate. So if you take an aqueous solution of silver nitrate and you have a aqueous solution of potassium chromate and you add them together, you have this kind of reddish substance that forms. That's an indication of a chemical change. This is a solid. This is silver chromate. And this silver chromate is what we call a precipitate. A precipitate is a solid that forms from the mixing of two aqueous substances. And all this, this might look like it's being dissolved, but based on the density of the precipitate that forms, the precipitate could sink to the bottom, or it could rise to the top, or just be within the solution. Regardless, you have a solid, and the formation of the solid is indicative that you have a chemical change. Okay, another example is a change in temperature or a formation of gas. If you take solid sodium metal and you have water, you might have seen this reaction on YouTube or something. Sodium solid is very, very reactive, and if you have water, if you add water to it, you have this kind of explosion. And this explosion causes, of course, a change in temperature, releases a lot of heat, and it forms gas. In this case, the gas that's being formed is hydrogen gas, and you have sodium hydroxide also being formed. So a change in temperature and the formation of a gas can indicate that you have a chemical change. By the way, if you're ever in this scenario, don't try to put out this fire with like water or like carbon dioxide fire extinguishers. You need a special type of fire extinguisher to put out this fire. And sodium fires are very, very dangerous. So make sure you know what you're doing before you handle sodium metal. Okay, and now we get to my favorite part. None of it matters. If we look at a change in temperature example, let's look at a cold pack. In a cold pack, what you have is ammonium nitrate, and inside a pouch you have a bag of water. If you've ever used a cold pack, you know that you kind of just squeeze it, and then what happens is that this pouch holding water, it explodes, and then the water mixes in with the sodium nitrate. Now, there isn't actually a chemical reaction happening. What's happening is that ammonium nitrate is dissolving in water. And as we discussed, just dissolving something isn't a chemical change, right? But the reason a cold pack works is because dissolving ammonium nitrate is very endothermic, meaning it takes a lot of heat from the atmosphere or from its surroundings, and it makes itself very cold. And so you have something that's on two sides. You have a change in temperature, and you also have what is really just a phase change. And that's the problem with identifying something as a physical or a chemical change. Saying something is a physical or a chemical change kind of says that the world is absolute. And in reality, the world is not absolute. You don't have something that's really a physical change or a chemical change. These are all kind of made up. And so there are certain things that are purely physical changes, like, boiling water to produce steam, or a chemical change like forming a precipitate. But you also have some examples that are ambiguous. You have examples that could go kind of both ways. And for that reason, you really shouldn't beat yourself up if you can't distinguish between whether or not this is a chemical or physical change, because frankly, no one knows and no one cares. There are certain things that are physical changes. There are some things that are chemical changes, and you should know those ones. But don't worry if you don't know everything. And that was it. That was 4.1. That was the difference between physical changes and chemical changes. I hope you learned something. I hope you enjoyed this video, and I'll see you later. Thank you.